Hello, you guys. So we're going to now work with the graphing motion question. So then make sure that you saw the graphing motion review so that you can understand why or how to answer these questions. Right here it says a hobbyist collected data about the motion of a toy train on a straight track. So this is a toy train on a straight track. And then record the data in the graph below. So the possible answers say, or the question says, which of these accurately describes the motion of the toy train? So then we're going to look at the possible answers to see what it is that they want us to do. So the toy train speeds up while going forward and then slows down. The toy train slows down while going forward and then moves backward. The toy train moves forward at a constant speed, slows down, and then stops. The toy train moves forward and increases speed, stops, and then moves forward. If you remember when we were talking about the distance graphs, and here it says from starting point, and we said that these are talking about position. So this is not speed. We're not going to look, oh, it's speeding up. It's slowing down directly when looking at the data. We're looking right here at meters and we're looking at seconds. So then remember that when we're talking about distance graph, this means a straight line means that I'm going at a constant speed. So then I could say that from 0 to 2 minutes, the object was going constant. And then we see where the line curves a little bit. This is where the object is slowing down. And we can actually check this information because look at the amount that it traveled from 2 to 4. From here, from 2 to 4, it traveled a total of, 2. It only traveled, 1.5 meters. So then right here, it slows down. And then right here, it stays at the same place. Right here, this is when we say it is going constant. It is at rest. Okay, so then right here, a toy train speeds up. No, we said it was going constant. The toy train slows down. You know what? We did say that it was going constant and then it slows down. So let's see what else we have here. Slows down while going forward and then moves backward. It never moved backwards. So then I'm going to say no. The toy train moves forward. It was going forward. It was going at a constant speed. We say that it slowed down and then it stopped. I think this is the right answer. The toy train moves forward. It did move forward at an increasing speed. No, it actually went constant and then it slowed down and then it went in. It got at rest. So then my correct answer is going to be letter C. Number 42. Right here. Okay, it's right beneath number 25. So a student graphed the position of a cart during a 7-second time interval. So we're looking at 7 seconds. So it goes from 0 all the way up to 7 seconds. Which statement best describes the cart? So let's look at the possible answer. The cart was stationary with a velocity of 0 meters per second for the entire 7 seconds. The cart was stationary except for a short burst of acceleration of 0.5 meters per second. The cart moved at a constant velocity of 0.5 meters per second for the entire 7 seconds. The cart accelerated at a constant rate of approximately 0.8 meters per second. So then right here, let's go ahead and look at the formula. We're going to look at the formula for speed. So I'm going to get my formula chart. So for the formula chart for speed, we have speed equals distance over time. So then I'm going to draw my formula triangle. And with my formula triangle, I'm going to say that letter D is up on top over here on the formula. So I put it at the top of the triangle. And then, of course, my T and my S, I'm going to put them at the bottom. So once we have that formula triangle, and I'm still going to put speed equals d over t. Okay, so that I can have the formula there as well. So now I need to see the speed of the object. So what am I looking for? I need the distance and I need the time. The distance we have right here, the time we have right here at the bottom, that it is 7 seconds. So I'm going to put my time. And when I do this, guys, I actually put speed, distance, and time. So I have my time is 7 seconds. And now I need my distance. So for my distance, I'm going to count from 2 all the way up to 5.5. Okay, because it made it all the way to 5.5. So then it started here and it ended up right here. So then what do I do? So we won't make any mistakes, guys. We always get the ending time and then the starting time to get the distance traveled, and we get from when it started. Okay, so here it didn't start from 0. So then what I'm going to do is that I'm going to get my calculator and I'm going to put right here 5.5 because it traveled all the way to 5.5 meters. So 5.5, and I'm going to put minus, it started at 2, it didn't start at 0. So then minus 2, and that's going to give me 3.5. Okay, so then once again, I put the 5.5 minus the 2 because it didn't start at 0 and it was 3.5. And this is going to be my distance. So I label it so that right now I'm going to plot in the distance. So 3.5. And we're talking about meters. So then now I need to find my speed. So I cover the letter S and it says that I need to solve for d over t. So then I'm going to put my 3.5 meters and then my 7 meters. My 7 seconds right here over 7 seconds. So let me go ahead and get my phone again. And let me go ahead and put right here 3.5 divided by 7. And I got 0.5. So then I'm going to put right here my answer is going to be 0.5 meters per second. That's my answer. So then let's go ahead and see right here what we have as possible information. The cart was stationary with a velocity. It was not stationary. It was going, right? If it was stationary, it would have been a horizontal line. The cart was stationary except for a short burst. No, it was never stationary according to this. The cart moved at a constant velocity. It is at a constant velocity, so that is true. Of 0.5, look right here, 0.5 meters per second for the entire 7 seconds. And this is correct. We got the average from beginning till end. And I'm going to put a question mark. The cart accelerated. There was no acceleration. If there would have been acceleration, we would have seen a curved line, kind of like over here on the previous question. We were looking at the information one section at a time, but we could have described this as accelerating at a certain time when it slowed down, and then also as it stopped. So then right here, my correct answer is going to be letter H. Okay, so now we're at page 40. And the next question is going to be, or is question 23. Question 23 on page 40. And it says the graph below shows distance over time. So we have distance in kilometers and we have time in minutes. It says which of these situations could be represented by the graph. So we have different situations and we want it to represent the graph. So let's read the possible answers. A student walks 1.5 kilometers to a friend's house in 40 minutes. The two students then walk another 1.5 kilometers to school in 20 minutes. A student walks 1.5 kilometers to a friend's house in 20 minutes. The two students then walk another 1.5 kilometers to school in 40 minutes. A student walks 1.5 kilometers to a friend's house in 30 minutes. The two students walk another 1.5 kilometers to school in 30 minutes. A student walks 1.5 kilometers to a friend's house in 20 minutes. The two students then walk another 1.5 kilometers to school in 60 minutes. So what they want us to do right here, guys, is actually we need to know how long it took to get from here to here and then from here to here. So then I'm going to go with speed equals distance over time. So then I'm going to get my formula chart again. So here we go. Speed equals distance over time. I'm going to put my formula over here. Speed equals distance over time. And of course, I am going to draw the formula triangle, and that's what I want you to do as well. So I'm going to draw my formula triangle, and I have the D at the top. So I'm going to put D at the top for distance, and then time, and then the speed at the bottom. So what am I going to do right here? I'm going to get my distance right here. Okay, my distance. My time. So my time is in 20 minutes, and my distance was 1.5. So I end up right here and right here. So then speed equals distance over time. Speed, distance, and time. And right here we're talking from 0 to 20 minutes. 0 to 20, not minutes again. 20 minutes, yes, I guess. So then right here, my distance, my time was 20 minutes. So I'm going to put here 20 minutes. And my distance travel was 1.5. Right here, 1.5. So then I'm going to put 1.5. So then right here, if I put D over T, I'm going to put D over T. Oh, and why am I doing that? Because I'm looking for the speed. So if I'm looking for the speed, I'm going to put right there D over T. So then right here, or you know what? Let me continue with this, and then I'll see if we need the distance over time. So then for the next one, okay, for the next one, I have right here my distance travel. So it was from here to all the way to the top. So then that means from here all the way over here. Okay, so then for the distance, it's going to be, what is it, 3 minus 1.5. So let me put 3. And why am I doing that? Because we are at the distance of 1.5 to 3. So then the 3 I'm going to put right here minus 1.5. 1.5. So let's see what that gives us. 3 minus 1.5. So I'm going to clear this calculator. Clear. So it's going to be 3 minus 1.5 equals 1.5. 1.5. This is my distance. Okay. Distance. And then my time. How long did it get me to get there? So then right here, a lot of us are going to tend to say 60 minutes. But remember, we're not talking about 60 minutes. We're just measuring from this to here. Okay? From this to here. And then we were measuring from here to here. And that one, and actually not from there to there. It would be from here to here. We took care of that already. So then I'm going to do 60 minus 20. 60 minus 20. So right here, 60 minus 20 equals 40. So in reality here, it was only 40 minutes. Okay. So then right here, 60 minus 40. Minus 20. Because it's up to the 20. Just like we did on the calculator, equals 40. So in 40 minutes. So then it says the student walks 1.5 kilometer. So then, yeah, the distance was 1.5 from 0 to 20 minutes. Over here, we went all the way from 20 to 60 minutes. So then the first one, a student walks 1.5 kilometers. Yes. To a friend's house in 40 minutes. No. They did it in 20 minutes. So that's not true. A student walks 1.5 kilometers to a friend's house in 20 minutes. You know what? We have it right here. From 0 to 20, that's what happened. It was in 20 minutes. So then the two students then walk another 1.5. Here's the other distance. 1.5 to school in 40 minutes. And this is what we have here in 40 minutes. So you know what? That seems to be correct. Okay. So first in 20 minutes. Yes. And then another 1.5 kilometers to school in 40 minutes. So then right here, we have what I think might be the answer. Student walks 1.5 kilometers to a friend's house in 30 minutes. No, it was in 20 minutes. Here it is. A student walks 1.5 kilometers to a friend's house in 20 minutes. Here we go. 20 minutes, 20 minutes. Then the two students then walk another 1.5 kilometers to school in 60 minutes. No, that would be from here to here. But remember, it was just from here to here. So that was in 40 minutes. So the best possible answer is the letter B. So for page 41, now we have question number 28. And it says, a car travels at a constant speed for 15 meters per second for 2 minutes. The car increases its speed from 15 to 25 minutes during the next minute. And then travels at a constant speed of 25 meters per second for 2 more minutes. 2 more minutes. Which of the following graphs best represents the car's motion during the 5-minute period? So let's go ahead and see over here. A car travels at a constant speed for 15 meters per second. Constant speed. So if you remember when we were talking about speed, if right here it's kind of like saying this car's going at 15 meters per second. Constant on a speed graph is going to be just horizontal. So then this one's going constant. This one, it's already giving me something from top to bottom. It's reducing speed. And this one is increasing the speed. It's kind of like I'm going 10, 20, 30, 40 miles an hour. So then, no. Now here I'm constant, and I'm here I'm constant. And I know that they're not giving us the exact time, but these are the ones that right now seem to be the best ones. So then a car travels at a constant speed of 15 minutes for 2 minutes. Meters per second, 2 minutes. And then the car increases the speed. So if I'm going constant and then I'm going to increase, that means that now I need to go 20, 30, 40. So then right here, it's going to be going up. This one's good. This one shows an increase. This one shows a decrease. So I exit out and I don't even need to read anymore. My correct answer is going to be letter F. So we're now at page 42. Let's read the information. A student runs 2 times around a running path at a local park. Each lap is 3 kilometers. The student completes this first lap in 20 minutes. So the first lap in 20 minutes. The student then sits at a bench and rests for 5 minutes before completing a second lap of 25 minutes. Which graph best represents the student's motion? So then once again, we're going to do this in a total of, we have, let me see, a student runs 2 times around a running path at a local park. Each lap is 3 kilometers. So then right here, distance. So that means that this is 0. This is 2 kilometers, 4, and 6 kilometers. Okay. So then one is kind of like showing when the student is going around one and then going around the next one as it continues. It says the student completes the first lap in 20 minutes. So then right here, we have 20 minutes, 20 minutes, 20 minutes, and 20 minutes. It says he continues in 20, he finishes in 20 minutes. Okay, so then the student completes the first lap in 20 minutes. The student then sits. So you know what? Right here, it continues. There's no stopping time. Right here, it seems like as if it was going a little bit faster, and then the angle becomes less steeper. So right here, I see a slowdown. So then this one continues. There's no stop, and this one slows down. These two show that right here, they remain at rest. So this is that shows that he's sitting. The only thing is that he sits on the bench and rests for 5 minutes. Here from 20 through 30, that would be 10 minutes. So half of it would be 5 minutes right here. Right here it goes from 20 to 30. So this is actually 10 minutes. This is 5 minutes. Not correct. Letter H is my correct answer. So here we have page number 43. We continue with graphing motion questions. So let's look at the question. This is question number 10. The graph below shows the motion of a ball rolling on a straight track. Sometimes these graphs, they kind of like get us confused based on the information, but remember, the motion is the one that was graphed, not the object that we were working with or the material that it was moving on. So it's what was the ball's average speed during the time represented in the graph. So then we need the whole time, okay? So then right here, we're going to get the formula because they're looking for the average speed. Again, average speed, or we usually just say speed equals distance over time. So then I'm going to put right here, speed equals d over t. And of course, I'm looking for the speed. So then what am I going to do? I am going to get my formula triangle. And I'm going to put right here, the distance is up on top over here. So I put it up on top. And then the t and the s, I put at the bottom. So now I'm ready to go. So then when I'm looking for the speed, is going to be distance over time. And in this case, total distance over the time. Distance over time. So then I'm going to put right here, and my total distance travel, when we look over here, guys, it's from 0 all the way to 10 meters. So I'm going to put right here 10 meters. And my time is going to be from 0 to 50. So I'm going to put right here 50 seconds. So then let me go ahead and get my calculator. And we're going to do distance divided by time. So I'm clearing right here. So we have 10 meters divided by 50 seconds equals 0.2. Okay, so there we go, 0.2. So it's going to be 0.2 meters per second. And I know that it's meters per second. There's the M and there's the S. So the correct answer is letter F. Always you look at the unit of measurements, just in case they put something else here. They might put 2.2s, but one's going to have the wrong unit of measurement. For question, well, we're on page 44, and this is question 34. So it says the graph shows the distance an object traveled in 11 seconds. Which answer choices best describes the movement of the object between the times of 0 and 6 seconds on the graph? So I only need from 0 to 6. Okay, so then from here to here, that's what I need. Okay, so then I see that this is distance. And remember that the distance, when we have a straight line like this, we're talking about constant. So then moving at a constant speed seems like it. Moving toward the north. Right there, it's really not telling us in which direction, okay? It just says that the object is traveling, so no, it doesn't show the direction. Accelerating is not accelerating, and it's not stopped. Okay, it stops from 6 to 10, but from 0 to 6, there's no stop. So then right here, it does this from 6 to 10. So then right here, and I'm talking 6 to 10 seconds, okay? So then the correct answer is going to be letter F. So now we're going to be working with question number 29, still on page 44. We have 44 there, 44 here. So then let's go ahead and see at what we have here. It says, a golfer collected data on the distance a golf cart traveled in a straight line and plotted it on a graph. So here's the graph. So we have the starting point. So we're talking about distance. We're talking about meters. And it says, which of these does not describe the cart's motion on this graph? So that means that 3 of these are going to describe it and 1 is not, and that is going to be the answer. So let's look at this information that we have right here. A, the cart moved 24 meters away from the starting point between 2 seconds and 5 seconds. So I'm going to go to 2 seconds and 5 seconds. So I'm going to go all the way over here and here, okay? So then I want to see how much was moved away from home. So this is right here, 26. It goes a little bit beyond 25. So then this is going to be 26. And right here we start 26. Right here we start at 2. Okay? So then it's going to be 26 minus 2. Yeah, I know you're saying it's 24. I'm still going to do my calculations. So 26 minus 2 equals 24. So right here, I'm going to put 24 meters. And the cart moved 24 meters away from the starting point between 2 and 5. That's what we had between 2 and 5. It was 24 meters from here to here. So then letter A, this is correct. I need the not. Okay, so this is correct. So there's going to be 3 correct ones. Whoops. Yeah, 3 correct ones and a wrong one. Now I'm going to go to B. The cart moved towards the starting point at a speed of 3 meters per second between 7 and 12. So then I'm going to go to 7 and I'm going to go to 10, 11, 12. It's right here. So I'm going to see right there. So it's going to be over here and then over here. Okay. So the cart moved towards the starting point at a speed of 3 meters per second between 7 and 12. So then right here, I need to get my distance and time and all of that. So then we're going to have, let me see right here. We said from 7 to 12. So right here and to 12. So then right here I have 26, 25 and a half. So this is going to be 26. So that I can get my total distance. And right here I'm going to have 10 and 1 is 11. So let me subtract those two. 26 minus 11. So it's 26 minus 11 equals, whoops, 26 minus 11 equals 15. So 15 is going to be my distance. I took care of this one. This one was A. So then this is B. Okay, so I have 15 distance. I need my speed. And then the time. So the time was again from 7 and 12. Right here, 7 to 12. So then 12 minus 7. 12 minus 7. 12 minus 7 equals 5. So then 5 is going to be my time. So then I'm going to do speed equals distance over time. My triangle, I put the D up on top, the T and the S. So then I need the speed. So it's D over T. So 15 divided by 5 equals, let's put it right here, 15 divided by 5 equals 3. So then it's going to be 3 meters per second. So letter B, 3 meters per second. That one's also correct. Now we have letter C. The cart moved 11 minutes towards the starting point between 8 seconds and 10 seconds. Here's 8 seconds and 10 seconds. So then right here, when I look at the very top, this one is 8 seconds, this is 25, so this is 24. 24. And then over here 10 seconds, we have, what is it, 15 and one more, 16. So 24, this is C. 24 minus 16. Let's get that calculator. 24. Let me do it over here. 24 minus 16 equals 8. So for letter C, this one says 8, this one says 11. So then this one should be 8. This one is incorrect. This might be it. Now let's go ahead and look at D. For letter D, the cart moved away from the starting point at a speed of 1 meter per second for 2 seconds. So we're talking about right here. Okay. So then for right here, I have 2 as I'm going up. 2 is my distance and 2 seconds is my time. So then I'm going to do, for letter D, speed, distance, and time. So then we said my distance was 2 and my time was 2. So then speed, D over T, D over T, 2 over 2. Let's do the calculations. 2 divided by 2 equals 1. So then right here, 1 meter per second, 1 meter per second. That's my answer for D, and that one is correct. So then my correct answer is going to be letter C. That's the one. That's the one that is wrong. And here's my calculations. My paper was a little bit lower and we couldn't see it, but there it is. Okay guys, so this is page 45. And we have question number 40 right here. And this is our last one for the last section. Excuse me, I'm going to move the paper up just so that we can see all of the information. So let me go ahead and see if I can make it a little further away. Let me see right here. I just want to make sure that we see everything. Okay, here, more or less. There we go. So then right here, it says, students slid a small wood block along a flat tabletop for a distance of 1.6 meters. The data shows the motion of the block of wood. So then we have right here, the distance is 1.6. So, okay, we just kind of like focus on this. And it says, which graph displays the motion of the wood block? So all that we're going to do is get this information and we're going to graph it. So it's kind of like as if we were doing it on graphing paper, but we're going to match the one that is going to display the motion. Okay, so we say time is over here, guys, and the time is at the bottom and the distance is at the top. Okay, and we're talking about speed, it really doesn't matter because all we're doing is graphing. Now, if we were to interpret the graphs, then that would be totally different. But here we're going to graph, see what graph is correct. So seconds, or the time is going to be 0.0, 0.0, 0.0, and 0.0. And my speed is going to be 2.6. So 0.0, 2.6, more or less, I think that's right. This is 0.0, and this is giving me 1. Yeah, it's giving me like 2.6. But this is 0 and 2.6. So then this is not good. Okay. This was the first one, 0. And it's actually giving me, this would be 1 and 2.6. So right here, when we look at this information, guys, we see that the speed is going from 2.6 to 2.2 to 1.8 to 1.4 to 1.1 to 0.06. So then right here it's telling me that we're talking about the speed decreasing. So it's not supposed to go up, it's supposed to go down. So then automatically, right here, speed, they're all speed. So automatically this one is going to go out because this is increasing speed. Here it's decreasing. This one's staying the same. So we get rid of that one as well. These two are decreasing. Okay. So then we say at 0.0, 2.5, 0.0, 2.5. It might be 2.6. It goes a little bit beyond. So we're going to say, okay, that one, it matches. And then at 0.2 time, we get all the way over here, and this one ends up at 2.2, and this one is like a little bit more than 2. So it's 0.2, 2.2. This one is 2.1, but you know what? I'm going to go one more just to make sure. So I'm going to go to the third one, and I'm going to say 0.4, and it's 1.8. 0.4, this one's 1.5, 0.4, and right here I have 1.5, 1.8. So then this one's wrong. This one is correct. And then if I want to continue, 0.6, 0.14, and here it's 0.14. And then 0.8, and we have right here 1. And then we go to this one right here. Okay, so we have the speed is 0.6. There we go, 0.6, and we end up with 1. So then this is the correct answer. So the correct answer is letter J. Thank you so much, guys. I'll see you. Make sure that if you want to challenge yourself, go ahead and pause. And I should have told you guys at the beginning, right? Kind of like pause after each question. So I'll go ahead and see you guys. Enjoy the rest of your weekend. We have one more assignment coming, and that recording should be up tomorrow. Thank you, guys.